Hello, welcome to our video solution to problem 10 from Superquiz 1. This is a very special problem. It's not something you maybe are typically seeing in a Calc 2 course. It actually comes from the Romanian journal Gazette Mathematica. It turns out, though, some of the techniques we've been working on in this class will make it very straightforward to compute. So we define a sequence of numbers a sub n, and each one is defined as the integral from n to 2n of this crazy function, 1 over x times e to the 1 over x. And we really don't want to integrate this directly, so we're going to see what we can do with it. And the goal, right, is to compute actually the value of an as n goes to infinity. So, of course, this should be an n here. All right, fine. What do we do? Well, let's make an observation. We know that e to the 1 over x, right? What's happening with e to the 1 over x? Well, as you go from n to 2n, there should be some relationship, right, between those. So if you have e to the 1 over n and e to the 1 over 2n, let's see. 2n is bigger than n, which means that 1 over 2n is smaller than 1 over n. All right, 2n is bigger, so the fraction is smaller. But the exponential is an increasing function. So if you put in a smaller input, you're going to get a smaller output. So you should get this. And if x is in between n and 2n, then e to the 1 over x is going to be smaller than e to the 1 over n, and bigger than e to the 1 over 2n. Maybe equal, depending on if you let x equal n or 2n. Okay, but what that means then is that this function, when I multiply by 1 over x, so 1 over x times e to the 1 over 2n will be less than or equal to 1 over x, e to the 1 over x will be less than or equal to 1 over x, e to the 1 over n. And therefore, if I integrate from n to 2n, well, look at this e to the 1 over 2n, that's not going to have an x in it. I can actually pull that out. Let me pull that out of this first term. E to the 1 over 2n, then I just have 1 over x dx is less than or equal to, okay, now I integrate from n to 2n, 1 over x, e to the 1 over x is less than or equal to the integral. Okay, again, I'll pull out e to the 1 over n, x from n to 2n, 1 over x. Whoops, we forgot our dx's here. Okay, so we're trying to understand this quantity, that's a sub n, but we've now put a bound, right, an upper and a lower bound on it. So let's try to compute these. Well, this is actually the same, right, on both sides, so we just compute it once. This is going to be ln of, we'll normally say the absolute value of x, but since everything is positive here, this is just ln of x, evaluated between n and 2n, which is ln of 2n minus ln of n. But now we can use a log property. This is ln of 2n over n, right? The difference of logs is the log of a quotient. And this is just ln of 2. So the lower bound is the natural log of 2 times e to the 1 over 2n. And the upper bound, right? Well, this is the exact same quantity here. That's ln of 2. And so the upper bound will be e to the 1 over n times ln of 2. And so a sub n is bounded above and below by e to the 1 over 2n times ln of 2, and on the upside, right, the top side, e to the 1 over n times ln of 2. Okay, but now what happens as n goes to infinity? On the left side, the exponent goes to 0. And so you're getting e to the 0, which is 1, so this whole thing will just go to ln of 2. But the same exact thing happens on the right-hand side. As n goes to infinity, 1 over n goes to 0. E to the 0 is 1 times ln of 2 is ln of 2. All right, so a sub n is bounded above and below by sequences which are both going to ln of 2. And so by the squeeze theorem, it has nowhere to go. It also has to go to ln of 2. And therefore, the limit as n goes to infinity of a sub n is ln of 2. Woo! Nice contest problem right there.